Hello, I'm going to go through exam VWO 2019, Tijdvak 1, the first period. There were no exams in 2020 because of COVID. So what I'm going to do here is just to show a total of 9 or 8 exams. I'm going to go through 2019 with 2 exams, so together with 21, 22, I have a total of 8 exams. So question 1 is about a circle where we have the center given, the radius, and we also have a line K which obviously goes through the origin, and then this intersects the circle in 2 points, and we have to calculate the coordinates. Okay. So in this exam I'll also show what are the kind of the relevant subdomains that you need to be aware of to answer the question. Well, one is it has a vector representation. This is part of subdomain E3. Then there is a circle that is part of subdomain E2. And yeah, that is, you need to know of a circle what is the equation. So let's apply that. Let's write down what we know. We know the circle. So it has to be x minus 1 squared plus x minus 7 squared equals, the radius squared is 25, and for the line we can very easily convert this into parametric representation. So it's x of t is simply t, and y of t is simply 2t. And now they have to intersect, so we have to find for which t these x and y's are on the circle. Oops, what's wrong with my y here? So substitute it, then we get t minus 1 squared plus 2t minus 7 squared is 25. Now get all the like terms together, t squared plus 4t squared, it's 5t squared. Use the FOIL methods or whatever method you want to get rid of these brackets. You get minus 2t, but here you get minus 14 times 2 minus 28. So you get minus 30t. Probably you should just write it down one more time in your exam just to avoid mistakes. And you get a 1 squared and a 49 squared, so it's 50. It's 25, that looks good. So just write it down like this. I can just factorize 5, so it's 5 times, and I can divide out 5, so minus 60 plus 5 is 0, so t, and then just try to by trial and error try the different factors of 1, so 1 and 5, minus 1, minus 5, well there you go, minus 1, minus 5, 0, so t is 1 or t is 5, and then you can find the coordinates easily. Substitute these, so you get 1, 2, 10. And you can always double check that by substituting this back in the circle. In question 2, we have a function f and g given by the following. G is intersecting the x-axis and a. Function f has various extremes, all with a positive x, and point B is the third one of these extremes. And you have to show that this point is to the right of A. So that's 1, 2, 3. You can see it from the graph. But show this with the derivative of f. And here, that's a very elementary thing you need to know. It is related to domain C, that you use the derivative to verify the location of extremes of the function. So let's find out where A is first. And so that's actually the domain B, I think, about equations. So what this gx has to be 0 . So it means the square root of 2x is 3. I'll square them, so I get 2x is 9. So x is 4.5. And then we just need to know the x, so we don't, oh, well, the y is 0 as a matter of fact, of course. Okay, we need to determine the extremes of f, so we need to set the derivative equal to 0. Well, what is the derivative? That's 3 times minus the sine 2x, so that's application of the chain rule, times 2, and then we have 2x for minus 1/2, so I get minus 1/2 2x minus, which is minus 1 over the square root of x. That's not pretty. Where was I? I was putting, okay, so this has to be 0. So I get minus 6 sine 2x minus is 0. And this is not done easily, analytically, as far as I know. But there's no need for that. There's no need for any exact calculation, so I just put it in the graphic calculator, or I'm using Wolfram Alpha, and you just define this function and find what the intersections are with the x-axis. So minus 6 sine 2x minus 1 over minus is equal to 0. And it gives this set of solutions. So x1 is 1.6, x2 is 3, 0, and x3 is 4.75, which certainly is larger than 4.5. So I have answered this question. Next, question 3. We have a function fp, p greater or equal to 1, and it is shown for several values of p. And they also give a line k with this equation. Then they say this line k is a tangent of fp for every value p greater or equal to 1. So this skill is related to the tangent, and that's also how to use the derivative to find the tangent of a function. Subdomain C1. Well, let's calculate the derivative of fp. And note, so there's like a infinite number of functions, and they all have a derivative which also would depend on p. Well, if all is well. So derivative of p, you get 1. Then we can use the chain rule. You get 1/2 from differentiating this square root, and to the power minus 1/2. And with the chain rule, you need to do the derivative of x minus p, but that's just 1. So we get 1 plus 2 divided by the square root of x minus p. And then we just need to show that at some point x, at some coordinate x, this is equal to 1, which is the slope of k. Well, this obviously cannot be 1, but well, it is if x goes to infinity, but then wait, did I do something wrong? I did something wrong. Yes, guys, don't do this at home. I need to differentiate with respect to x, which I did properly here, but p is just a constant. Oops. Okay. Alright. So, can happen. This has to be equal to 1 for a certain x. So, I simply get 2 times the square root x minus p is equal to 1. I take the square, both sides, I get 4 x minus p is equal to 1. I want to isolate x, so well, let me just remove the parentheses. You see how easy it is to make mistakes. So 4x is 1 plus 4p, or x is p plus 1/4. So, and this x, this values of x, the function has a slope of 1. But a tangent is also needs to intersect that point. So let's check that. Well, you can already believe that. So what is, and so the y's have to be, the y of this line has to be the same as the y of the function. So what do we get? We get fp of like an x where there's a extreme. So x, let's call this xe, is fp p is p plus the square root of p plus 1/4. What is my x? Minus p. That is equal to p. Fortunately, the p's drop out here, so, and the square root of 1/4 is 1/2. And so this is for function fp, the y value of the tangent with a slope of 1. And where, so now we need to figure out where that is located. What is the x? Well, x is p plus 1/4. So this is I call this xe again, is a xe minus 1/4 plus 1/2 is xe plus 1/4. So then you can see that yeah, the y values of these points with slope 1 are indeed on this line and independent of p. Question 4. This graph fp for p greater or equal to 1 has a randpunt. That's probably boundary point or begin point, like entry point. And these are given by the dot here. That's obviously why they call it like a boundary point. And they say for every p greater or equal to 1, this boundary point is also on the graph of fp minus 1. And then we have to prove that. Okay, let's find out the coordinates of this boundary point. And obviously it's coming from the requirement that the square root of x minus p here is greater or equal to 0. So we need to have x minus p greater or equal to 0, or x greater or equal to p. So the x coordinate of this randpunt, let's just call it r, is p. And what is the y coordinate? Well, let's call that yr, would be the function p evaluated at this randpunt x coordinate. Substitute it, you get p plus the square root of p minus p of p. So this is our randpunt. And now we have to prove that this point is also on fp minus 1. Well, so we have to prove or show that f of p minus 1 evaluated at p is equal to p. And what is f p minus 1 of x is p minus 1 plus the square root of x minus p minus 1. And let's then evaluate that at x equals to p. So you get p minus 1 plus p minus p minus 1 is, well, this is just the square root of 1. The minus 1 drops, so we get p. So we have proven it. Question 5. We have a point A, which is the randpunt from f1, and we have point B, which is the randpunt from f2. So B is on the graph of f1. Yes, that's what we just showed. And then there's a line L going through A and B, and phi is the area enclosed by L and f1. Calculate exactly the area of phi. Am I missing something here? I'm not sure why this information is relevant actually, that B is a randpunt. Well, let's see. We know A and B, and we know f1, and we just need to find out the line L. Well, the L slope is by minus bx. Sorry, no, it's not. It's a difference of the y's. divided by the difference of the axes. A is 1 divided by 1. And it has to go through A, so which is 1, 1, so actually the intercept is 0, so this the line L is just, oops, the expression of the line L is given by y is x. So we just simply now need to calculate this integral exactly of, what was the function again? And p is equal to 1, in this case 1 plus the square root of x minus 1 minus x so these are standard functions for which you know the primitives, so you get x and you get x minus 1. This is a power 1/2, so I add 1 to the power, gets 3 over 2. But since if I differentiate it, I get this factor 3 over 2, which I need to compensate for. So it's 2/3. And here I get minus 1/2 x squared between 2 and 1. Well, just substitute, right? Get 2 and 2 minus 1, well, to any power is 1 to this power, so I get 2/3 minus 1/2 4 squared, 2 squared is minus 2, and then minus 1 0 negative minus 1/2 these drop, so 2/3 minus 1 plus 1/2. Just put them under a common denominator of 3, so I get 2/3 minus 3/3, a common denominator of 6. Well, I would have so I get 4, 6 minus 6, 6 plus 3, 6 is minus 2 plus 3 is 1/6. Slingshot at amusement park. Not sure if you guys are in the mood for that now, but okay. So we have the slingshot, basically 2 of these posts with 2 kind of short elastic cords, and the capsule, where I guess where you can have 2 persons, is in the middle. And they first kind of pull this thing down to the ground level. and then they will shoot this thing right vertically up, and after some time the capsule will kind of sit still in some place in between. And we have the post 14 meters, there's actually a drawing here, 14 meters from each other. They're vertical, they're 20 meters high. The length of each is 8 meters if they're not stretched. And each one will be pulling on the capsule with a force Fk. So it's not the total force, but it's the force of each elastic rope. And here, so F is the magnitude of the force, and L is the length of each rope. So this is 8 meters, this is 8 meters. And here this is the situation drawn out. And then they ask what is the magnitude of the force in the beginning situation, so when the capsule is kind of pulled to the ground floor, and give your answer in 1 decimal. Well, we just have to apply this equation here and figure out what L is. See, this L is of course increasing because you're stretching this these ropes here. Okay, well, we have Pythagoras, so we know the distance from C to a post, and we know the vertical distance, so we can calculate what L is. Well, L is the square root of 14 divided by 2, so it's 7 squared plus 20 squared. It's the square root of 49 plus 400. Uh, 449. No, that's not a whole number, but that's fine. We have to calculate to a decimal. Let's just, well, we immediately know the answer. Fk is 0.6 times this square root 449 minus 8. So we just put that in the calculator, 0.9 times 449 minus 8. And what's that? 7.9. Let's do 1 decimal. And what is it? Kilo Newton? Yeah. Okay, the two forces on the capsule can be represented with 2 vectors. Fk here, and you can calculate with this equation. It's and the vertical component of the vector is 2 times Fk times the cosine of alpha. That makes sense. It's 2 because you have two forces. And then you also, of course, have the gravity working on that in the z, also vertical direction, working down. And it's 1.8 kilonewton. That's for the 2 persons and the capsules. And furthermore, there is a height difference of x between the capsule and the top. And at a certain moment it will be at standstill, and at that point the force on the vertical force on the capsule will be the same as the force of gravity. So, well, let's just find what is F k v as function of x. So let's find f as function of x, and we do this in the same way as we did for the situation where it was completely at the bottom. So we can calculate the length of the rope, and we find that this L, that's now actually also a function of x, right, is equal to square root of 7 squared plus x squared. And the force Fk is, so Fk of x is 0.6 times that square root minus 8. And we find that f k v of x is then twice, so that's 1.2 times 49 plus x squared minus 8 times the cosine of alpha. And what is the cosine of alpha? Alpha is here. It's this length here, x. So cosine of alpha is x divided by L. So it's x divided by square root of 49 plus x squared. So I get the equation let me still just call this L, because there's to keep it a little bit more simple. We get then 12 L minus 8 times x divided by L is equal to Fz, but Fc is given by 1.8 already. What did we Well, we had to express it in x. Actually, I didn't read the question carefully. We have to express f kv into x. And so that's one thing. And then find, yeah, that's actually this thing here. So I guess to give the answer, so let me do that first then. That's the first part of the question. Oops, the lag is terrible. The f kv of x, the final expression, is then the very ugly equation of 12 well, I just write it out. Maybe this is not the most pretty way to write it down, but it is definitely what they're asking for. This exactly gives your vertical force as an expression in x. And then now we need to set that equal to 0. So I need a little bit more space for that. So now we just say that this has to be equal to 1.8 kilonewton. kV x is 1.8, and probably you can do this analytically, but it's really messy with the square roots. So we just put this in the calculator, and I just now did that, and then you find 7.25. So 1 decimal. Was that 1 decimal? In whole meters. So it's x is 7.25 meter, so that will be 7 meter in a whole number. And what they will actually the height above ground level, so there will be 20 meters. 20 minus 7 is 13 meter. Question 8. Two functions given, and we need to calculate the intersection. Gx is the derivative of f, for which we use the expression that you need to know of the product of two functions. So x, the first one is x, the derivative of x is 1, so I get log x, plus x times the derivative of log x, so that is plus x, and then divided by x. Then we get the derivative of minus x, which is minus 1, and derivative of 1 is 0. So it's just log x. And then set it equal to f, I get log x minus x plus 1 is equal to log x. We just move the log x here to the left, minus x plus 1. And you can, if x is not equal to 1, you can divide by, well, we just factorize x minus 1 actually. This is x minus 1 times log x, and this is minus x minus 1. So you get this, so that means x is equal to 1, or log x is equal to 1, which means x is e to the power 1. So x is e. Yep, that answers it. There is a value for p for which this integral is equal to 0. And that's sketched here. Calculate exactly this value of p. And write your answer in the form p is a times e, with a number. Alright, not. Okay, the integral of gx, so we need to have a primitive of g. Meaning a function that when you take the derivative is g. And that's already given here. So we don't even need to know what it is. But actually, if you want to know, the primitive of log x is actually x log x minus x plus some constant. Okay, so let me just. This is then the f at 2p minus f at p. So that is 2p log of 2p minus 2p. You have a plus 1, but that will cancel here, so I don't write it down. You get minus p log p minus p. So you can, let's just clean this up a little bit. Oops. Two p log 2p minus p log p minus p and a negative here, so get minus p. So what I can do is, I obviously see there's the common factor p, and I get 2, well, let me still write it out, minus log p minus 1 and let me already just set it to 0. So that means that p equal to 0 or that other thing is 0. And what I can do here is realize that 2 log 2p is the log of 2p squared. I want to combine this in one logarithm. Was I correct here too? Yeah. So I write this, well, or that thing is 0. Can p be 0? Well, obviously, yeah, if p is 0, this is the lower and upper boundary are the same. So that's kind of a trivial solution. Now let's look at the other. So, and I write this already as 2p squared minus log p minus 1 is 0. And then I can put them under one logarithm. So I get 4p squared divided by p, so that is 4p minus 1 is 0, or that means log 4p is 1, which means that 4p is e to the power, so I take, basically I use that e to the power a or b, it means that a is equal to b. So I basically use this to the left. So p is, well, a quarter times e. So a is 1 over 4. F given by this fraction, quotient of two functions, a line k, which is horizontal. It intersects the function f in a infinite number of points. So this function will repeat to the left and the right, but here they only show the first smallest positive x coordinates, point A and B here, and find the x coordinates of A and B. Okay, so we need to solve cosine x divided by minus sine squared of x is equal to the y value of the line, square root of 2. So with these things you always try to express it in the similar cosine or sine, but in this case it's you can immediately see and convert everything in cosines, and you get cosine of x divided by minus 1 minus the cosine squared of x is the square root of 2, which we can rewrite as cosine x equal to minus square root of 2 plus the square root of 2 times the cosine squared of x, and we can bring the cosine here to the right, so we get square root of 2 cosine squared x minus cosine x minus the square root of 2 equals 0. Again, with these things, just double check everything because if you make a mistake, things get very ugly. Okay, minus is a plus square root of 2. And let's just define u as the cosine of x, and then we can just write it as a quadratic equation in u. Get the square root of 2 u squared minus u minus square root of 2 equals to 0. And it's also a little bit easier with these things to get the coefficient in front of u squared to be 1. So I divide by the square root of 2. I'll get u squared and 1 over the square root of 2 is 1/2 the square root of 2. You have to know how to get rid of square roots or roots in the denominator just by multiplying both by the square root of 2. So you get minus 1/2 square root of 2 u, and minus 1 is 0. So now we're going to see if we can write it in this kind of form. We have this nasty square root of 2 here, but let's still try it. So obviously this is a minus 1, so minus 1 and 1 won't work. You don't get the square root of 2, but from this you can kind of, as a hint, try a combination of 1/2 square root of 2 and the square root of 2, because multiplied these are 1. So let's try a minus 1/2 square root of 2 here and the square root of 2 here. So I get from the two outer terms I get minus 1, alright, and for the other cross term I get minus 1/2 square root of 2 times u plus the square root of 2 times u, which is plus, which is incorrect, but I can easily fix that. Make this, and now I get minus 1/2 square root of 2u and the minus 1 here. So I find u is minus 1/2 square root of 2, and or u is the square root of 2, but since u is cosine of x, this can never happen, or any x. So I have as solutions the cosine of x equals minus 1/2 square root of 2. And for these you just have to know your known angles for the cosines and sines. This is one of the standard values of cosines. Actually the cosine of pi over 4 is 1/2 square root of 2. And you can either use the unit circle or some other way to figure out what solutions are. And you have to find the smallest ones. Which are x is So that happens when half pi plus a quarter pi. That is, well, let me write it down. Half plus, that is times pi, so that is 5 over 4 pi. And it also happens, so if you draw the unit circle, I'm the worst circle drawer, but so it happens here and here, then the cosine are negative. So the other one is 1/4 pi past pi. So that is pi. So that is 1 plus 1/4. Ah, no, this is wrong. This is 3/4 pi, of course. And the other is 1 plus 1/4 pi, so it's 5 over 4 pi, which should be the answer to this question. Best is just quickly plug it in your calculator, just to double check it. You still best to remember them, but it doesn't hurt to double check. It's definitely easy to make mistakes. Question 11. We have a function fp given, meaning an infinite set of functions for every value of p. And this asks to investigate the values for p for which this graph has perforaties, which are discontinuities. And usually these are of the form, say a function g of x is x over x, and yeah, these are kind of lame functions, but strictly speaking they are not defined when for x equal to 0. These are non-permissible values, they're not in the domain of this function. But you can investigate exactly what happens there if at that point the function actually approaches a finite value, then it will have a so-called discontinuity. So that is and that happens of course because both the numerator and denominator go to 0. So this will be just a line, well, mostly y equal to 1, but it's not defined in x equal to 0, but again the limit is finite. And yeah, you what you do is just find where this denominator gets 0 and then calculate the limit, and that you do just by simplifying this thing and find that it is equal to 1. And it's not always equal to 1. You could have x squared divided by x, for example. That's also not allowed at x equal to 0. And the limit, no, that's not, this is, should say, x over x squared. That's not defined at x equal to 0, and if you take the limit, You simplify this to 1 over x, then it goes to infinity. So what are the non-permissible, non-allowed values of f of p? Well, if the sine squared of x is equal to p, this is not defined. These x's here are not in the domain of the function. So the question is, do you get finite values for these? For the function? And well, if the sine squared of x is p, then it means 1 minus the cosine squared of x equal to p. So for all these x's, the cosine squared of x, bring this to the right, this to the left. Let me just take the square root. Is the square root of 1 minus p. And since the cosine here is in the numerator, will be actually non-zero mostly actually non-zero for all p not equal to 1. So that's not a discontinuity. No discontinuity. Let me abbreviate it. But it could happen when p equals to 1, because then both the numerator and denominator go to 0, but we have to investigate it. It doesn't mean necessarily it is a discontinuity, right? Like in this case here. So let's investigate p equal to 1. Then the function f1 of x is given by cosine of x divided by 1 minus the sine squared of x. But this one is just equal to cosine x divided by the cosine squared of x is 1 over the cosine. So does this function f1 have a discontinuity? No. This is actually a continuous function, except when this cosine x gets 0. But if that happens, it will have the limit goes to infinity or doesn't exist. It's probably the proper way. So this is this function has no discontinuity. So we have shown then that for every p there is no discontinuity. Question 12. In the remainder of this question, we limit ourselves to the values of p for which p is not equal to 0. Then there are 3 points on the graph with coordinates 0, pi, 2 pi, which we call p, q, and r. And here's for a particular value of p. The graph is given. Then you can define segments pq and qr, and it's stated there are values of p for which p, q, and qr are perpendicular, and calculate exactly these values of p. Okay, that's not so tough. Well, the slope of PQ would be the y of q minus the y of p divided by the x of q divided by the x of p. So it's yq minus yp divided by xq minus xp. Well, what is yq? That is the function f p at what was it, pi. The cosine of pi is -1. The sine of pi is 0, so that's that. And yp equals cosine of 0 is 1. The sine of 0 is 0. And let's actually, since I'm on it, also calculate yr. That's at 2 pi. Well, cosine of 2 pi is 1. The sine of 2 pi, of course, is 0. So I get 1 over p again. See, there's actually the same level as p, of course. What was I doing? Okay, the slope SPQ is then minus 1 over p minus 1 over p. So that's minus 2 over p divided by x. So this is at pi. The delta x is pi. So it's minus 2 divided by p pi. And the slope of QR that's then the y of r minus the y of q. Well, let me still write it out. yq x of r and the x of q. What is the y? It's 1 over p minus negative 1 over p. So I get 2 over p. And again, the horizontal distance is pi. So it's 2 divided by p pi. And as very common in these exams, you need to know that in order to be perpendicular, the product of these has to be -1. So we get minus 4, multiply these, so I get p squared pi squared equal to -1. In other words, p squared pi squared equals 4 or p equals 4 over pi. Or minus, no. Okay, so basic stuff here. Let's just write it out. I'll get p squared equals 4 over pi squared that means, remember, as part of the basic skills, a squared is equal to b squared. That means, see, it works in both ways, that a is b or a is minus b. So get p equals to plus or minus the square root of this thing, which is 2 over pi. So these are the two possible values of p. Okay, question 13. We have a line k going through these 2 points A and B. There it is. And a curve given by this parametric equation describing a point P moving along it. And that curve is a line M, actually. And for almost every position of B, these three are a triangle. But there's an exception. So for some value of P, this thing is not a triangle here. Well, that makes sense because line K and M cross or intercept at a certain point. And then that means that A, P and B are on one line. So let's calculate that intersection. So we need to get an expression for the line K, and well, that's, again, the slope is the y coordinate of B minus the y coordinate of A, that's minus 10, divided by the x coordinate of B, 40, minus 0, so it's minus 1 over 4. That roughly makes sense. Just look at here, it goes to 10, here's to 40. And I also immediately know then the expression of the line, because in this slope-intercept form, y is mx plus b. M is the slope and b is that y-intercept, so I get y is minus 1 over 4 x plus 10. And I want to intersect with this, so I just substitute let's see, what's the best way to do this? I substitute x and y of this line, of this curve, parametric curve. So I get 30 minus 3t is minus 1 over 4, 18 plus 5t plus 10. And then I find my t. If I know t, I substitute it here and I find point B. Did I do that correct? I think so. So we can just bring all the terms of t to the left at minus 8t. No, not minus 8t. Let me just carefully write it down. This is 5 over 4t. And I get minus 30 minus 18 over 4 plus 10. Again, this is very error prone, so check it again. The line makes sense. Did I substitute it? Alright, I think so. Okay, put these under one denominator, 4. So I get minus 12 over 4 plus 5 over 4 t. This is 9 over 2. So I put it under denominator of 2 at minus 60 divided by 2 minus 9 over 4. 9 over 2. Plus 20 over 10. So I get minus 17 over, no, see how easy it is to make mistakes. Minus 7 over 4t. Minus 69. My God, what am I doing here? I was going to bring it under denominator of 2. So minus 60 minus 9 is minus 69. Plus 20 is minus 49 over 2. Which follows that t is 4 over minus 7 times minus 49 over 2. 49 over 7, that's good. This is 4 over 2 is a 2. So I get 2 over 2 times 7, 49 over 7 is 7. So t is 14. And then substitute that, I get the px is 18 plus 60, 78. Not 60. 5 times 5 times 14, 70 plus 20. 50 plus 20. Okay guys, don't do this at home. Is 88. What actually and we also need the y coordinate. Py is 30 minus 3 times 14. 3 times 14 is 42. So 30 minus 42 is minus 12. So p equals 88 minus 12. That probably roughly makes sense looking at this Alright, the last question. Investigate algebraically if there's a certain P such that the triangle ABP has a right angle at P and the triangle ABP is gelijkbenig, which means it has two equal sides, and the sides have to be AP and BP, because the right triangle angle is here. If you have a right triangle with two equal sides, these have to be the two legs here, because the hypotenuse cannot be of the same length as the leg. So let's demand that the vector pointing to P from A and to P from B are perpendicular. So we set the vector P minus A in the product with P minus B is 0. So Px is known as 18 plus 5t. Ax is 0. And Py is 30 minus 3t minus A y minus 10. Again, I get my px, but now there I have a 40, and I have my 30 minus 3t. Well, if that has to be 0, that means 18 plus 5t times actually, right, doesn't matter, but I prefer to put the t's in front. It's 5t plus 18 times 5t, and 18 minus 40 is 22. And here I get minus 3t. 30 minus 10 is 20. And minus 3t plus 30 has to be 0. So 25t squared then I do 5t times minus 22, which is minus 110. Sorry guys, bear with me. It's very error prone, so need to be careful. 5 times 18 is 90. 18 times 22. That's too complicated. It's minus 396. And here I get the 9t squared, and minus 3t times 30 is minus 90, and I have to subtract 20 times 3, so I get minus 150t, and 20 times 30 is 600. 0. Okay. Alright, so 34 t squared. And how many t's do I have? This is minus 20. And this is minus 150. Oh, I get minus 170 t minus 396 plus 600. I can do that by head. It's 204. All right. Well, let's just check. End of the exam, so you can use your calculator. Okay, so you can divide 170 by 34. It's 5 and 204 as well. That's a miracle, guys. So t squared minus 5t plus 6 is 0. Alright. That shouldn't be too difficult. So t, trial and error, 1 and 6 doesn't work. Minus 1 and minus 6 doesn't work, but 6 minus 6 minus 6 and minus 1 doesn't work. Okay, let's try 2 and 3. Yeah, t minus 2, t minus 3 is 0. So t is 2 or t is 3. And now we need to find the length of P A and PB for this T. Alright. Let's see if there's an easier way. P squared. I don't know. Just substitute it. So the norm of B minus A, I can just look at the square. And so for, let's do it for t equals to 2. I get 18 plus 10 squared plus, let me just, because I'm getting out of space, 18 plus 10 is just 28. 28 squared. 30 minus 6 is 24. And P minus B, the norm squared, is I think I didn't no, I didn't take this minus 10, so it is 20 minus 6, it's 14 squared. And P minus B squared for t equals to 2, so it's minus 22 plus 10 is minus 12, so I get a 12 squared. And 30 minus 6 plus 24. Okay, just use your calculator. I check alpha, or Wolfram alpha. Last question, guys. 28 squared plus 784. I think most people of you probably already can tell immediately. 12 squared plus 24 squared, 720. So it's not these sides are not equal. T is 3. I get 18 plus 15 is 33. Uh, 20 minus 9, 11 squared for this. And for the other, so minus 22 again, plus 15. It's minus 7. 30 minus 3t is and yeah, you can immediately tell actually the 33 is larger than 21, 11 is larger than 7. Actually, I could have done that here as well. I wouldn't even need to calculate it. But probably just in exam, I'll just still, particularly if you have time, just try that out. And yeah, we find that these lengths are not equal in both cases. So the answer is no. They are not vorm een gelijkbenige driehoek. Well, it was not the last question. There's a question 15 about a parabola. We have a function f(x) is the square root of x. It's given here. And then we have 2 points A and B. And a point M in the middle. And now I can do the rotation around the x-axis. So you get an omwentelingslichaam, which is called like a rotational solid. I think there's another exam when that was asked, so although that was a rotation around the y-axis. But around the x-axis is a little bit more easy actually. But you need to know both. I checked it up. You need to know about these so-called omwentelingslichamen, both for rotations around the x-axis as well as around the y-axis. So every point on the graph will describe a circle when you rotate it around. And then you can define a circle A, or the area of a circle which has die beschreven wordt door het punt M. So that's a circle sitting right here in the middle, and I guess they mean the center point of this. No, I guess this is the radius. So yeah, you get a circle with a radius square root of m given the function. Okay, so that's A. And then we see this rotated a little bit, and they define h, which is the height of this parabola, or what's the right term in English. Then they say for the volume of this body or solid, we have that it's equal to the height times the area of this circle sitting in the middle. Okay. Well, all right. So what you have to know, as I mentioned, you need to know how to calculate these rotational bodies and the volume of them. And that is just something that you need to know, so I can just write it down. You have for phi, the volume, is equal to the integral from a to b of the function squared, so fx squared dx times pi. Oops, don't forget the pi, because that's comes in from the area of the circle. So you're kind of summing all these circles here. The area times the every time is a very small height increase. Let me just write that properly. And well, the nice thing, fx squared is just x. So that's not difficult. That is just the primitive of x is 1/2 x squared. So you have to evaluate this thing between b and a, and that is 1/2 pi b squared minus a squared. But now we have to express this in h and a. Well, what is a? A is the area of that circle, and that area is pi times basically the value of the function at m, so it's square root of m. I think that's what they meant here as well. So it's pi m. Excuse me. But okay, now you wonder what is m. I just want to express it in my b and a. Well, that's actually straightforward. M is the height, so it is b minus a. Okay. And what is h? H is No. That's not true at all. M is the middle. M is the middle. So it is 1/2 A plus B. Okay, and I think it's working out. The H is this distance here, so that's B minus A. And that means that phi calculated in this way is B minus A times pi but so this is, you can easily check B minus A and A plus B is minus A squared plus B squared. So I get my half, I get my pi, I get my B squared minus A squared, and well, these two are the same. So yeah, I've proven this